Right, the graph shows y is equal to x squared minus 3x minus 1. So here we've got the graph of y is equal to x squared minus 3x minus 1. Use the graph to find solutions for the following quadratic equation to one decimal place. We've got to use this graph given to solve x squared minus 3x minus 1 is equal to 0, x squared minus 3x minus 5 is equal to 0, and x squared minus 2x minus 6 is equal to 0. So it's a typical sort of IGCSE question. Right, so in the first case we had to solve x squared minus 3x minus 1 is equal to 0. So here's my graph. Right, so all I need to know is where is y is equal to 0. So this is the line here, y is equal to 0, which is the x-axis. So we need to see where the curve cuts the x-axis. So to show the examiner, we need to put on a point here and read off carefully the scale, minus 0.3. And here also read off the scale 3.3, and then write down the solutions. X is equal to minus 0.3 or 3.3 to one decimal place. That's the degree of accuracy expected for this type of question. Part B, we need to solve x squared minus 3x minus 5 is equal to 0. So here is my graph. I've got the graph of y is equal to x squared minus 3x minus 1. So we will need to make the left-hand side of this equal to x squared minus 3x minus 1. So if we add 4 to both sides of this, that minus 5 plus 4 will make that minus 1. So that's the graph that we got. And on this side we've got 4. So we will need to draw the line y is equal to 4 onto the graph. So if we draw the line y is equal to 4 onto the graph. Now, there is the point y is equal to 4. Everywhere along this line here, y is equal to 4. So draw the line on accurately as possible and write on y is equal to 4. And the intercept will give us the solution. So mark on the intercept. So looking for the intercept of the line and the curve. So we've got that one here coming down, and read off carefully the scale, minus 1.2. The other one here, and you need to show this on your graph how you got the solution. Gives me 4.2, and therefore the solutions are going to be x is equal to minus 1.2 or x is equal to 4.2 to one decimal place. For part C, we had to solve x squared minus 2x minus 6 is equal to 0. And we need to make the left-hand side of this equal to x squared minus 3x minus 1, because that's the graph it's given. So in order to do that, we will need to take an x, that will make that 3x, and we will also need to add 5. Minus 6 plus 5 will make minus 1. Minus 2x minus x will make minus 3x. We'll do that to both sides. So, doing that to both sides, this side becomes x squared minus 3x minus 1, which is what we want, the same as our curve. And then 0 plus minus x gives me minus x, and then plus 5. Alright, we need to draw the line y is equal to minus x plus 5 onto our graph. We need to be careful, because that's 1 unit on the x-axis. This is 1 unit on the y-axis. Using the idea of y is equal to mx plus c. So c will be the 5, so mark on plus 5, and then a gradient of minus 1 means for every one along we're going to go 1 down, so the next point will be there. So 2 of these little squares here makes 1, 1 here makes 1, so that's a gradient of minus 1. We continue that pattern across the curve, across the graph, going backwards, and taking our ruler and as accurately as possible draw on a line and label it y is equal to minus x plus 5. And look for the intercepts. So the intercepts are going to be here and here. So the first one is going to be minus 1.6. And the second one here is going to be 3.6. So the solutions are going to be x is minus 1.6 or 3.6 to one decimal place. So this has been a video to show you how to use a particular quadratic equation to solve other quadratic equations. I hope you've understood, and I thank you very much for watching.